All right, guys, today we're moving on to 2.6a. We're going to be finding the domain, poles, and vertical asymptotes of these rational functions. So a rational function is a function that has a polynomial on the top and on the bottom of a fraction. So remember, a polynomial is just an equation that has all positive whole numbers for exponents on the variables. So in order to find the domain, remember domain is all the x values that you could plug in for these x's here and then evaluate. So on a rational function, the denominator can never equal 0. That's because dividing by 0 is undefined. So what we need to do here is we need to take the denominator to find the domain. We need to take the denominator and we need to set it equal to 0. Find the x values that make, or that we'll need to exclude. Those x values that make it equal 0 are the ones that we will need to throw out of our domain. So what we're going to do is we're going to, sorry, one second. We're going to take and set our denominator equal to 0. But the only way that we can solve this little equation, since it's a quadratic equation, is by using x factoring. So we're going to x factor this denominator. So a is 1, b is -5, and c is 6. So 1 times 6 goes up here. That's we need two numbers that are going to multiply to 6 and add to -5. So that would be a -6. Nope, that wouldn't work. I was going to say -6 and +1. That will work for -5, but that won't give us a +6. So actually here, I think we need to use 2 and 3. So let's try that again. So if I do -2 times -3, that's going to give me a +6. And also -2 plus -3 is -5. So that gives me, on my function, it would equal -x plus 3 on the top still. On the bottom, we have x minus 2 times x minus 3. So again, remember, in order to find those x values we need to exclude, we're setting this equal to 0. So that means when x equals 2, my denominator would go to 0. And also when x equals 3, my denominator would go to 0, right? Because 3 minus 3 is 0, and then 0 times whatever is 0. So these two values will make my denominator equal 0. And because we do not want our denominator to equal 0, these are the two x values that need to be excluded. So what this means is that we can plug any x value on the whole number, real number line in for x on this function, except for 2 and 3, because 2 and 3 will give me a 0 denominator. Okay, so that is what the domain, that's what we're looking for when we're looking for the domain. So same thing on the second one. I'm just going to take the denominator only. I'm going to set it equal to 0, and then I'm going to factor it. Notice here that these two terms have a common factor of x, so I can just pull an x out. So this one is just x times x minus 3 equals 0. So if x equals 0, or if x equals 3, those are going to make my denominator become 0. So I would have to exclude these from the domain. So the domain would be any real number except for 0 or 3. All right, so on the second part, it's asking me to find the domain still, but then it's also asking me to find something called the holes in the function. So holes are a little discontinuity. So if I were to like sketch a graph, if I have a piece of a function that is a rational function, usually they look something like this. They'll have like two curves. A hole would be a little spot in there where there's not a point. And those happen where there's a matching factor in the numerator and the denominator that cancel out. So if you're asked to find holes and the domain, you're going to need to factor the numerator and the denominator. Okay, if you're just asked to find the domain, you don't need to worry about the numerator. You can just factor the denominator, but since here we're being asked to find the domain and the holes, we have to factor both. So let's start with the top. They have x to the third, x squared, and -2x all have a common factor of x. So I'm first going to pull that x out. That would leave me with x squared minus x minus 2. And then I can x factor this stuff that's in the parentheses. On the bottom, I also have a common factor of 3x. If I pull 3x here, I'm going to be left with x minus 3. Remember, you can always double check. If I were to multiply 3x back into the parentheses, I should get the same thing as here. So on the denominator here, I'm already done. There's nothing else I can do to factor it further. On the numerator, we need one more step. We need to x factor the part in the parentheses. So a is 1 and c is -2. So I need two numbers that will multiply to -2 and add to b, which is -1. So that would give me that would be -2 and +1. So this top part is going to factor to x times x minus 2 times x plus 1. Whereas on the bottom, I have 3x times x minus 3. All right, so let's actually find the domain first. It's actually a good idea to find the domain first because then we're going to find the wholes, and the wholes are going to be canceling things out. So the domain here, because of the denominator, remember only look at the denominator when you're talking about domain, is going to be x cannot be 0, because if x is 0 and I put a 0 right there, I'd have 3 times 0 times -3. Because of that times 0, it would give me 0 on the bottom. So I'm just taking that 3x and setting it equal to 0 and solving, right? 0 divided by 3 is 3. So that's where that x equals 0 comes from. For x minus 3, it can't be not -3, +3. So my two exclusions are 0 and +3. The domain can be any x value except for those two numbers. As far as the whole goes, wholes are going to be occurring where factors cancel out. So because I have an x on the top that's going to cancel with an x on the bottom, there's going to be a whole at x equals 0. So it's the 0 for where that happens, where that canceling out happens, right? So here we have a whole at x equals 0. So let's actually skip down and let's try number 6. So we're going to factor the numerator and the denominator, but in this case, the numerator doesn't need to be factored. It's already factored. So we're just going to factor the denominator. I'm going to use x factoring again. So -12 is the number we need to multiply to, and -1 is the one we need to add to. So that would be -4 and 3. So this is going to factor to x minus 4 times x plus 3. So the domain is going to exclude 4 and -3 because those are the two values that make the denominator equal 0. So again, x cannot be those two numbers. It can be anything except for those two numbers. And then for the wholes, I'm looking for matching factors in the numerator and denominator. I have an x plus 3 that's going to cancel with an x plus 3. And because those cancel out, there's a whole there. The whole is at the 0 for that factor that canceled out. So it's at -3. Okay, let's try number 8. So again, factor the numerator and denominator each as much as possible. On the top, I can just pull out an x, which would leave x plus 4. On the bottom, I can pull out a -3, which would leave me with x plus 3. So here, the domain is that x can be anything except for -3, because that -3 would make my denominator equal 0. And here, there are no wholes, because there's no factor that cancels out. There's no matching factor in the numerator and the denominator. All right, so this next section, the change is that now we are looking for what's called a vertical asymptote and the domain. So a vertical asymptote is on a graph. It's a line that the function won't touch or cross. So it's a vertical line, so it might look something like this. And that's just a line that the function may like come up to, but it's never going to touch it or cross it. And so a lot of times on these, they'll actually have two pieces that will look something like this. But those vertical asymptotes are another discontinuity in the function because it's a break in the smoothness of the curve or whatever. So this vertical asymptote is found by also factoring, because we're going to have to find any place that's a discontinuity or that is restricted in the domain. So any of those zeros on the bottom that are not wholes are going to be vertical asymptotes. So I'll show you what I mean here. So in number 9, again, we're asked to find the domain, so we need to factor the denominator. But because we're asked to find vertical asymptotes, we'll also need to factor the numerator. So the numerator has a common factor of 3x. I'm just going to, 3x squared. I'm going to pull out 3x squared. That will leave me with x plus 2. Again, double check, make sure if you multiplied it back through, you get the same thing again. On the bottom, I'm going to pull out an x. That's going to leave me x squared plus x minus 2. And then this piece in the parentheses that has 3 terms, I can use the x factoring on that. So the top, 3x squared times x plus 2. The bottom, I have x. And for x factoring, I need two things that multiply to negative 2 and add to positive 1. So that'd be 2 and negative 1. So x plus 2 times x minus 1. All right, so the domain, we just need to look at the denominator only. We have 0, negative 2, and positive 1 are the restrictions. The domain can be any x value except for those 3 because those are the ones that will make my denominator equal 0, and we can't divide by 0. This one's not asking me to find the wholes, but I know there is a hole there because x plus 2 is going to cancel with x plus 2. So if I were being asked to find a hole, I would say there is one at x equals negative 2. Remember, it's at the 0. And the reason that I wanted to cross out that x plus 2 is because these two factors that are left on the bottom after anything cancels out, that's where there's going to be a vertical asymptote. Although I just realized there's an x squared here and an x here. So remember, x squared is the same as x times x. And if there's one x here and one x here, those will also cancel. So there's also a hole at 0. And so the only one left on the bottom is x minus 1. That is going to be where the vertical asymptote is. It's going to be at x equals positive 1. So again, it's the 0 from this factor. So after you've canceled out any matching factors, the leftover on just the denominator, the 0 for those factors are going to be vertical asymptotes. Okay, so your domain excludes all the zeros from the bottom from the denominator, and then those are made up of either holes or vertical asymptotes. So all of these points, these 0, negative 2, and 1 that were excluded from the domain, they are always going to be either a hole or a vertical asymptote, one or the other. Okay, so let's try another one. So on number 10, we're going to go ahead and factor both the numerator and the denominator. So on the top here, we would have, since we have negative 2 and positive 1, again, it would be 2 and negative 1, so this would be x plus 2 times x minus 1. On the bottom, negative 3x minus 3, they have a common factor of negative 3, so I'll pull that out, and that would give me x plus 1. So double check, negative 3 and x is negative 3x, negative 3 times 1 is negative 3. So that works out. So the domain here has to exclude negative 1 because that would make our denominator equal 0. So do the domain first, then look for holes. Here there are no holes because nothing cancels out. And again, this didn't specifically ask us to find holes, but we always want to check for things that cancel out before we find the vertical asymptotes. So anything that did not cancel out that's still on the denominator that would make the denominator equal 0, that's a vertical asymptote. So x equals negative 1 is our vertical asymptote. Okay, so notice here that when I am finding the domain, I'm finding that 0 and I'm excluding it. I'm saying x cannot equal negative 1. When I'm finding a hole or a vertical asymptote, I'm going to say it does equal that, okay? Because that is where that discontinuity happens. So just keep that in mind as you go through. Let's just do one more example here. So number 11, go ahead and factor the numerator and the denominator. We're going to use x factoring on both of them. So we'll have something like this. So on the top here, I need two numbers that multiply to negative 8 and add to negative 2. So that would just be negative 4 and 2. So here up here I have x minus 4 and x plus 2. On the bottom I have a common factor of negative 3. So the first thing I'm going to do before I x factor is I'm going to pull that common factor of negative 3 in front of the parentheses, which would leave x squared plus 2x minus 3. And now I can x factor this stuff here. So I need two numbers that multiply to negative 3 and add to 2, which would be 3 and negative 1. So I would have a negative 3 out here in front of these parentheses because of this negative 3 here, but this would just become x plus 3 and x minus 1. So on this one, the domain would be x cannot be a negative 3 because that would make this one go to 0. It cannot be a positive 1 because that would make this one go to 0. Remember, we only care about the denominator going to 0. I would have any holes if any of these canceled, but they will not cancel on this one, so there's no holes. And then the vertical asymptote, in this case, there are two, because there were two factors in the denominator and neither one of them canceled out. So there's a vertical asymptote at x equals -3, and there's also one at x equals 1. Okay. So on this last section, it's just asking you to find all three, even though in that middle section, we kind of did that already. So you're going to find the holes, vertical asymptotes, and domain. Remember to do it in the order, though. I think it's a little bit easier if you do the domain first, then the holes, and then the vertical asymptotes. So first step on all of these is just to factor, factor, factor. So factor the numerator. That becomes x times x plus 2. I'm just pulling out that common x. In the denominator, there's a common factor of 2. So that would leave me with x squared minus 2x minus 3. Make sure you always check for a common factor first before you start x factoring. So I need two numbers that multiply to -3 and add to -2. So this would give me, let's see, +3 and -3 and +1. So I would down here, I would have 2 times x minus 3 times x plus 1. So the domain cannot be, x cannot be 3 or -1 because those would both make the denominator equal 0. Remember, we only need to look at the denominator for domain. For holes, we need to see if there's anything that matches on the top and the bottom. Since this one has no matching on the top and bottom, there would be no holes. And then the vertical asymptotes are, again, those zeros from the denominator that weren't holes. Okay. All right, last example. Let's just do one more. We'll do number 18 here. Pull out a common x here. That would leave x squared minus 4. And then on the bottom, pull out a common factor of 4. That would leave me with x squared minus 2x minus 3. So I'm just taking the common factor first. X is still squared here, so I can still factor that. This is the same as x squared plus 0x minus 4. So when I x factor, I'm looking for two numbers that multiply to -4 and add to 0. So that would just be -2 and 2. -2 times 2 is -4. -2 plus 2 is 0. So on the top, I would have x times x minus 2 times x plus 2. On the bottom, if I x factor, I'm looking for two numbers that multiply to -3 and add to -2. So again, that's -3 and 1. So x minus 3 and x plus 1. So the domain is going to exclude anything that makes the denominator equal 0. So 3 and -1 in this case. The holes are going to be where any zeros where there's a matching factor in the numerator and the denominator that cancels out. No holes in this one again. And the vertical asymptotes, after you've canceled out any holes, you just look at the denominator again, and the zeros from the denominator are where your vertical asymptotes are. So x equals 3 and x equals -1. All right, guys, good luck with this, and I hope you have a great day. Bye.